In order for an ordered pair to be a solution to an equation, the left side has to equal the right side when we substitute that point in for x and y. So let's do two examples to make it clear. Example 1 is negative 1, 6, a solution of y equals negative 4x plus 10. We just need to plug this point in, and if we plug it in, let's see whether our left and right sides match. So coordinate points are written x, y, so I need to plug in a negative 1 here for my x, and I need to plug in a 6 here for my y. All right, let's simplify that right-hand side. Negative 4 times negative 1 is positive 4, and 4 plus 10 is 14. So is 6 equal to 14? No. So that means that negative 1, 6 is not a solution. Second example is 4/3, 8, a solution to 9x squared minus y equals 8. Well, just like before, let's take that x and y, and we are going to sub in 4/3 for my x, and we're going to sub in an 8 for my y. You can multiply this out on your own. You need to square 4/3 and then multiply by 9, and then subtract 8. I'm going to use my calculator though, because I think most of you will also use your calculator. So make sure you put the 4/3 in parentheses and then square it. It's not really a problem here, but if you had had a negative number, you wanted to make sure that you squared the negative number. Okay, so everything on the left-hand side is now typed into my calculator. If I hit enter, it equals 8. I bet you're surprised to see that. One example of yes and one example of no. Anyhow, there you go. So in order for it to be a solution, plug it in to your equation, and if the left side equals the right side, then yay, it's a solution. If not, it's not a solution. All right, what if I give you a graph though? It's not much different if I give you a graph. So example 3 is 2, 3 a solution to this graph. All it means for a solution to be on a graph is this an actual coordinate point on this curve? 2, 3 would be right here. That is on my curve, so my answer is yes. If they had asked me, is 2, negative 1 a solution? Well, 2, negative 1's down here, which is not on the curve, so your answer would have been no. Just show you one example of each. All right, and then example 4, this seems very difficult because now you have to create your own solutions, but it's not too bad. So find a solution to 3x plus y equals 9. The good news here is there are a million different ways you can answer this and still be right. There are also a million different ways you can answer this and be wrong though, so make sure you know what you're doing. For this, you can just pick an arbitrary x or y to plug in. The easiest one is probably say x equals 0. Or x equals 1, y equals 0, y equals 1. It doesn't really matter what numbers you plug in. Just choose some number to plug in for x or y, and then solve for the other number. Let's do 0, because that's really easy. So let's plug in a 0 here for x. 3 times 0 is 0. So that means that y equals 9. So if I have the coordinate point x equals 0, y equals 9, and if I plug it back into the original equation, when I plug it back into the original equation, 3 times 0 is 0 plus 9 is 9. It equals the right-hand side, so this is a solution. I can come up with more solutions. Let's plug in a 1 instead. So what happens if I sub in a 1 for my x? All right, well, this would be 3 plus y equals 9. Subtract your 3 over to the other side to get a 6. So the coordinate point 1, 6, y equals 6, x equals 1 is also a solution. You could do this again, plug in a 2 for your x, plug in a 3 for your x. You can plug in fractions if you want to. I just like to keep it simple and plug in zeros or ones because that way you don't have huge numbers to worry about. And again, you don't have to just sub in for the x. What if I decided to plug in a 0 for y instead? I would have 3x plus 0 equals 9, so 3x equals 9, so x equals 3. So my coordinate point 3, 0 is also a solution. I could plug in a 1 for my y, 3x plus 1 equals 9. So 3x equals 8 if you subtract your 1 over, and x equals 8/3. I don't like fractions, so this one's not as pretty to me, but that is also a solution. All 4 of these are solutions because if I plug them back into the original equation, the left side will match the right side. And side note, this is the y-intercept, and this is the x-intercept.